Hello, everyone, and welcome to CBSE's first personalized chapter model tuition. So now we've completed the chapter Is Matter Around Us Pure, right? So now, since you're going through your schooling period, exams are an inevitable part of schooling. So, what should we do? We must make sure that we are prepared to face any exam that comes our way. So, in today's session, we are going to be discussing a few important questions from the chapter Is Matter Around Us Pure? So, I'd suggest you sit along with me with a pen and notebook and solve the questions along with me so that we'll be able to do this together side by side. Okay? Fine. So in this session, we'll be discussing questions from multiple sections. Okay, we'll be having multiple choice questions. We'll be having short answer questions, very short answer questions, assertion and reason based questions, long answer type questions, and case study questions. Okay, so shall we start? Yes. So firstly, we'll start with multiple choice questions. So what is the first question? Which of the following is not a homogeneous mixture? So we know that mixtures are classified into two types, homogeneous and heterogeneous. What is the speciality of homogeneous mixture that is in question? Number one, the mixture has got a uniform composition. That is, there is an even distribution of substituents in the mixture. What is the second point? There is no separating boundary between the constituents. There is no separating boundary between the constituents. These are the most important points pertaining to homogeneous mixtures. There are other points also that we discussed. So here, what is the question? Which of the following is not a homogeneous mixture? So we are aware that air is a homogeneous mixture. It is a gas and gas type mixture. Tincture of iodine is also a homogeneous mixture. It is a solid in liquid type mixture. Sugar solution is again a homogeneous mixture, again falling into the same criteria, same category, which is solid in liquid type mixture. What about milk? Is milk a homogeneous mixture? No. We know that milk is a colloid. And what is the speciality of a colloid? A colloid is a heterogeneous mixture that appears homogeneous. So in reality, when you go to the molecular level, milk is nothing but a heterogeneous mixture. So the answer to your question is option D, milk. Milk is a heterogeneous mixture. It is a colloidal solution of water and fat. Okay, fine. So now we'll move on to the second question. What is the question? Which method is used to separate cream from milk? Just now we finished discussing that milk is a colloid. And what is the separating technique that helps us separate the dispersion medium and dispersed phase in a colloid? Remember, we discussed about centrifugation. Centrifugation is a special technique that is useful for the separation of the constituents in a colloid. So, centrifugation is the correct answer to separate cream from milk. Okay, I hope you're writing this down with me. Yes. What is the third question? Which of the following statements is incorrect about a physical change? So to answer this question in the first place, we must know what a physical change is. What is a physical change? A change which happens without altering the chemistry or the chemical composition of a substance is referred to as a physical change. It can be a change in size, it can be a change in state, it can be a change in shape, etc. So, what is the question here? Which of the statements is incorrect about a physical change? First one, there is no gain or loss of energy. There is no gain or loss of energy. Just give me a minute. Yeah. So there is no gain or loss of energy. So let's study this statement with an example. Consider the melting of ice. So ice absorbs energy from the surroundings and it converts into water. Now, while freezing water back to ice, what happens? This energy is being released into the atmosphere itself, into the surrounding itself, right? So that's why we say during physical changes, there is no gain or loss of energy. Energy is only being transferred. So the first statement is correct. What is the second statement? It is generally permanent and irreversible. Is it? We studied that physical changes are generally temporary and reversible. This is not true in all cases. Okay, generally, mostly physical change is temporary and reversible. Before marking the answer, we'll check for the other options also. Composition of the substance remains same. This is one important property of physical change, right? Composition does not get affected. So this is a correct statement. What about the fourth statement? No new substance is formed. Formation of new substances is an inherent property of chemical changes. So here, no new substance is formed in physical change is again a correct statement. So which one is our correct answer? It is option B. It is generally permanent and irreversible. That is the incorrect statement. What does the question say? Question says to mark the incorrect statement. So from the options given, the incorrect statement is option B, and therefore option B is our correct answer. Okay, so we'll move on to the fourth question. In tincture of iodine, find the solute and solvent. So even without looking at the options, I'm sure you'll be able to tell me the answer. Right, which one is the solute and which one is the solvent? Okay, since it is a multiple choice question, I'm giving you the liberty of the options. So what are the options? Alcohol is the solute and iodine is the solvent. Okay, number one. Option B, iodine is the solute and alcohol is the solvent. Option C, any component can be considered a solute or a solvent. Is that possible? No. In a solution, obviously there is going to be a solute and a solvent. Tincture of iodine is not a solution. Is that even a statement? We are aware that tincture of iodine is a homogeneous mixture. It is a solution. So which one is the correct answer? Is it option A or option B? We know that solute dissolves in the solvent. Solute dissolves in the solvent. And also, solvent is present in a larger quantity in comparison to the solute. So tell me, in tincture of iodine, which one is the correct, which one is the solute and which one is the solvent? It is option B. Iodine is the solute and alcohol is the solvent. So option B is again the right answer for this particular question. A solution of iodine in alcohol known as tincture of is known as tincture of iodine. There's an S missing here. A solution of iodine in alcohol is known as tincture of iodine. Here, iodine is the solute and alcohol is the solvent. So again, option B is our correct answer. Is it clear? Okay. So now we'll move to the fifth question. Which of the following properties does not describe a compound? So whenever you're looking at questions, especially multiple choice questions, carefully read the question. Okay. Here it says which of the following properties does not describe a compound. So what is a compound in the first place? A compound is a pure substance that is formed by the chemical combination of elements. Chemical combination of elements in a fixed proportion, in a fixed ratio. So these are the main phrases that should be present in your definition of a compound. So what is our question here? We have to find out the property from the option that does not describe a compound. Option A, it is composed of two or more elements. That is correct, right? It is formed by the chemical combination of elements. So this option is correct. It is a pure substance. Again, a true statement. Pure substances are divided into elements and compounds. So all elements are nothing but, sorry, all compounds are nothing but pure substances. What is the third option? It cannot be separated into its constituents by physical means. That is again a correct statement. Remember, we studied that compounds can be separated into their constituent elements only by chemical or electrochemical methods. So here option C is also a property that describes a compound. What about option D? It is mixed in any proportion by mass, meaning elements are mixed in any proportion by mass. Is that true? No. For the formation of a compound, elements must always combine in a fixed proportion. For example, let's take water. For us to make water, always two atoms of hydrogen must combine with only one atom of oxygen. If two atoms of hydrogen combines with two atoms of oxygen, we'll not get water. We'll get a different compound. So option D does not describe a compound, and hence option D is the correct answer for this question. Is it clear? A compound is composed of two or more elements in a fixed proportion by mass. It is a pure substance and it cannot be separated into its constituents by physical methods. So option D is the correct answer. Okay? Fine. Now, what is the sixth question? This question needs you to pay a little more attention. Okay, what does the statement 10% glucose in water by mass signify? So let's go back to our basics. We know that there are several methods of expressing concentration, right? There is mass by mass percentage, there is mass by volume percentage, and there is volume by volume percentage, which you have studied in class 9. So here 10% glucose in water by mass. What does this signify? This signifies our mass percentage. So here it is given that mass percentage of glucose in water is equal to 10. Now they're asking, what does the statement signify? So let's look at this as an example. Let's look at each option to find out the answer. So always remember, before you can solve these questions even without looking at the options. Always remember, if mass percentage 10% is given, what does it mean? 10 grams of solute is present in 100 grams of solution. This is the significance of this mass percentage. 10 grams of solute is present in 100 grams of solution. Now imagine if I've given the mass percentage as not 10 grams, instead I've given 5 percentage. Okay, instead of 10 percentage, I'm giving 5 percentage. So what would this signify? Should any changes be made to the things that I've written? Yes, right. It won't be 10 gram of solute anymore. It's going to be 5 grams of solute present in 100 grams of solution. This you have to remember always. Okay, mass percentage 5 percentage means 5 grams of solute present in 100 grams of solution. So with this understanding, now you would have obviously guessed the answer, right? Which one is the correct answer? It is option A. 10 grams of glucose present in 100 grams of solution. That is the correct answer. Now let us solve it using the formula that we know. So what is the formula of mass percentage? Mass percentage is equal to mass of solute divided by mass of solution into 1, sorry, yeah, into 100. Okay, so this is the formula of our mass percentage. So here, let's take, I've told you now we know that first option is the correct answer. So we'll solve with the first option itself. What does the first option say? 10 grams of glucose present in 100 grams of solution. So solute is glucose here. What is the mass of solute? It is 10. Now, what is the mass of solution? 100 grams of solution. So mass of solution is 100 into 100. When you solve it using the formula, you get the answer as 10, which is there in the question itself, right? 10 percentage is the mass percentage. So the correct option here is option A. Is it clear? Okay. So now we will move ahead. Now we are entering the next category of questions, very short answer type questions. So let's look at what our first question is. Find out the number of pure substances from the given list. So now I'll give you a few seconds. You can read the list and you can tell the answer. You can write the answer in your notebook. What are the substances given to us? Water, aluminium, brass, carbon dioxide, soda, gold, air, common salt, and vinegar. These are the substances given to us. We have to answer as to how many, the number of pure substances that are present in the list given. Okay, so first let's classify the substances in this list into elements, compounds, or mixtures. Okay, fine. So water, what is it? It is a compound. Aluminium is an element. Brass, what is brass? Brass is an alloy. Alloys are homogeneous mixtures. So obviously brass is a mixture. Carbon dioxide, it is a compound. Soda, what is soda? Soda is again a gas and liquid type homogeneous mixture. Carbon dioxide is dissolved in water. So it is a mixture again. Gold, gold is an element. Air, we know air is again a gas and gas type mixture. Common salt, sodium chloride, is a compound. Vinegar is again a liquid in liquid type homogeneous mixture. So this is again a mixture. So now we've classified the substances into compounds, elements, and mixtures. But what is the question? Find out the number of pure substances from the given list. For that, we should know what pure substances are. Pure substances are substances that are made only of a single type of particle. And we also know that pure substances are classified into two types. What are they? Elements and compounds. So what does that mean? From the given list, we have to count the number of elements and compounds, add it up, and write it as the final answer. So here, we'll start counting, okay? Compound, element, compound, element, compound. So we've gotten 5 pure substances from this list, right? Water, aluminium, carbon dioxide, gold, and common salt. So we have 5 pure substances in this list. So let's check if our answer is correct. Yes? Yes, the answer is 5. Water, aluminium, carbon dioxide, gold, and common salt. So do not get confused. Pure substances are classified into elements and compounds. So you have to pick both elements and compounds from the list and write the answer. Okay, fine. Now again, we have such a similar type question. Find out compounds from the given list of substances. In the first question, we had to find the number of pure substances. Here, we're not asked to find the number. We have to write down what the compounds are from the following list of substances. Okay, so I'll show you the list right away. Yes. Iron, soil, ice, mercury, carbon monoxide, and salt solution. These are your substances. Here also, I'm going to give you, say, 10-20 seconds. You can take your time and write down the compounds from this given list. Are you done? Yes? Okay. So again, we'll classify them into elements, compounds, and mixtures so that our process becomes a little easier. Iron is an element. Soil is a mixture. Ice. What about ice? What is ice? Ice is nothing but frozen water, right? So if water is a compound, ice is also going to be a compound. Mercury. Mercury is an element. Carbon monoxide. We know carbon dioxide is a compound. Is carbon monoxide a compound? Of course, it is a compound. When two elements combine in a fixed proportion chemically, we will get a compound. The formula of carbon monoxide is CO. Okay, so there's one atom of carbon and there's one atom of there's one atom of carbon and one atom of oxygen in carbon monoxide. Okay, so carbon monoxide is again a compound. Salt solution. If there was no solution, we could have written compound. But here it is salt solution, which is sodium chloride or common salt mixed with water. That is a mixture. So what are the compounds from the following list? The compounds are ice and carbon monoxide. Is it clear? Okay. Now we'll move on to our next question. Seawater can be classified as a homogeneous as well as a heterogeneous mixture. Comment. What would the answer be? This statement is actually true. Seawater can be classified as a homogeneous and a heterogeneous mixture. Look at the answer. If we consider the seawater on the surface, that is, if you take a mug and take some seawater from the surface of the sea, it comprises water and dissolved salts. There'll be salt dissolved in that water, and that is obviously going to be a homogeneous mixture. But if we consider seawater from the deep sea, if you dig your mug deep into the sea and if you take seawater, it consists of salts, of course, along with mud, decayed plants, etc. So that becomes a heterogeneous mixture. Okay, so if the question is filtered seawater can be both homogeneous and heterogeneous, that is false. Filtered seawater is always a homogeneous mixture. There'll be no plants, there'll be no animals, there'll be no mud. But regular seawater can be classified as both homogeneous and heterogeneous mixture. Okay, so this statement is actually true. Fine. So now we'll move on to the next question. How can you change a saturated solution to an unsaturated solution without adding any more solvent to it? Now, what is a saturated solution? You might be recollecting your memory right now, right? A saturated solution is a solution in which no more solute can be dissolved at a given temperature. That solution has attained its saturation. No more solute can be dissolved in it. Now, what is the question? We have to change a saturated solution to an unsaturated solution. What is an unsaturated solution? A solution that can dissolve more solute at a particular temperature. It can dissolve more solute. It is not saturated. So we have to change a saturated solution to an unsaturated solution without adding any more solvent to it. So what do we do? There lies one particular phrase in our definition. What is our definition of saturated solution? A solution in which no more solute can be dissolved at a given temperature. So if you increase the temperature, what can happen? You can dissolve more solute. So what is the answer? How do we increase temperature? By heating. Okay. By heating the saturated solution, it becomes unsaturated. So imagine you have dissolved, say, 25 grams of salt. Okay, let's say you have dissolved 25 grams of salt in 100 ml of water at 25 degrees Celsius, and this has become a saturated solution. Okay, so now to make this solution unsaturated, what should you do? You should just heat it, keep it on the stove, heat it. Then it becomes, the temperature keeps increasing, right? And then you will be able to dissolve more salt, meaning it has become an unsaturated solution. So the answer is, by heating the saturated solution, it becomes unsaturated. Is it clear? Okay. Now we go to our next question. Based on which factor a solution is said to be diluted, concentrated, or saturated? Which factor or which component decides or holds the power to classify solutions as dilute, concentrated, or saturated? It is the amount of solute, right? Amount of solute classifies a solution as dilute, concentrated, or saturated. So what is the answer? A solution is said to be dilute, concentrated, or saturated based on the amount of salt dissolved in a given solution. Is it clear? So the factor that we are talking about is the amount of solute. Okay? Fine. Now we move on to short answer type questions. So now we're done with very short answer type questions. We're also done with MCQs, multiple choice questions. So now we are progressing. We're going one step ahead. Short answer type questions. Smoke and fog are both aerosols. In what way are they different? Now, how many of you remember this question? Have you seen aerosols anywhere before? What are aerosols? Aerosols are nothing but colloids. So remember, what did I tell you? To study different, you have different types of colloids. You have foam, you have aerosols, you have emulsions, you have gels, you have a lot of different types of colloids given in your textbook. Right. So what did I tell you? I gave you a few statements which makes your studying process a little easier. Do you all remember it? Or do you need some time? Yeah? Do you remember? Yeah, I gave you a few statements that you would have written in your notebook. I want you to take this time and go through that. Okay? Before we discuss the answer. Okay. So aerosols, like we know, are a type of colloids. So if you remember, I told you, whenever the dispersion medium, whenever dispersion medium is a gas, then we call such colloids as what? We call such colloids as aerosols. Dispersion dispersion medium is a gas, then we call such type of colloids as aerosols. Right. So what would be the difference? You tell me, what would be the difference between smoke and fog? They're both aerosols, but they're different in some way. Their dispersion medium is the same. It is gas. Then what would differ? Yes, their dispersed phase would differ. What would differ? Their dispersed phase would differ. Both smoke and fog have gas as the dispersion medium. But the difference lies in the dispersed phase. The dispersed phase in fog is liquid, whereas in smoke it is solid. So dispersion medium in aerosols is gas, but dispersed phase in smoke is solid, whereas in fog it is liquid. Okay, see, you have questions from that portion also. So please pay some attention to that table that we studied in class. Is it clear? Okay, so now we will move ahead. Name the process associated with the following. I'm going to give you a few scenarios. You have to tell me the name of the process. There are processes that you have already studied in your lower classes also. So this is a very easy question. Okay. So first we'll look at the questions. Okay. Muddy water is allowed to stand and clear water is obtained on top. You take some mud, take some sand, stir it in water, and after some time what happens? You allow it to stand for some time. After some time what happens? All the mud or all the sand will settle at the bottom and clear water will be obtained on top, something of this sort. So you have a container, you have sand and mud or water, and after some time, after you have let it to stand for some time, mud or sand gets collected at the bottom and you'll get clear water on top. So this process is called as what? It is called as sedimentation. Okay, sedimentation. Fine. What is the next question? A beam of light passes through a mixture of water and milk and becomes visible. Where have we studied this before? You remember we studied it with an experiment, right? I showed you an experiment where you took milk in a glass of water, passed light onto it, and what happened? Light did not pass through the other way. Instead, milk got illuminated, meaning the path of the light inside the colloid became visible. So this process or this phenomena is called as Tyndall effect. Okay? Third question, very easy, something which you've studied in your lower classes, say 6th or 7th. Salt disappears on mixing with water. What is this process called as? You take salt, add it to water, and you stir it. This process is called as dissolution. You are dissolving a solute in a solvent. This process is called as dissolution. Milk is churned to separate cream from it. You churn milk. You would have seen your mothers or your grandmothers and all doing this, churning of milk to separate cream from it. What process is that from what we have studied? So we know that separating the dispersion medium and dispersed phase in a colloid is called what? that separation is done by what process? It is done by the process called as centrifugation. So churning, when you physically, you can either use a machine that will be faster and most effective, or if you even churn it with a ladle at home, that is also nothing but centrifugation. Okay. Next question. Separation of salt from water in a salt solution. What method can you employ to separate salt from water in a salt solution? Yes, it is boiling. By boiling, we convert all water in our salt solution into vapor and we'll be left with crystals of salt. Is it clear? Okay. Yes. Now, third question. You are given two samples of salt solution, 100 milliliter each, labeled as A and B. So you have two samples. Okay, just a minute. Yeah, you have two samples, A as well as B. Okay. Now, both are 100 milliliter each. Sample A has gotten 5 gram of salt dissolved in it, whereas sample B has gotten 12 grams of salt dissolved in it. Can you classify these samples based on concentration? Can you? What is concentration in the first place? Concentration is the amount of solute present in a given amount of solution. So here, based on concentration, we divide solutions into two types. What are they? Dilute and concentrated. When the solution has gotten a lower amount of solute, we call that solution as dilute solution. And if a solution has gotten a larger amount of solute, we call that as a concentrated solution. So here, sample A has gotten only 5 grams of salt dissolved in it, whereas in sample B, we have 12 grams of salt dissolved. What does it mean? It means that sample A is dilute in comparison to sample B, which is concentrated. Is it clear? Yes. Concentration is the amount of solute present in a given amount of solution. Here both samples contain 100 milliliters of salt solution. Solutions with a larger amount of solute is termed as concentrated, and the ones with a lower amount of solute is called dilute. So here sample A is dilute and sample B is concentrated. Simple. Look for the amount of solute. Whichever has a lower amount of solute, it is dilute, and whichever has a larger amount of solute is concentrated. Is it clear? Okay. Now we move to the fourth question. An element is sonorous, highly ductile. Under which category would you classify this element? What other characteristics do you expect the element to possess? Now we'll go back. Elements are divided into three types. What are they divided into? They are divided into metals, non-metals, and metalloids. Now here they're saying an element is sonorous and highly ductile. So when you hear these two terms, which category do you think this element falls into? Metals, right? We studied that metals have gotten a few inherent properties, and I gave you a mnemonic to remember the properties. What was that? Mud shell. So these are the properties of metals. They are malleable, they are ductile, they are sonorous, they conduct heat and electricity, and they are lustrous. So the element in question is without confusion a metal. So we can put this element under the category of metals. What other characteristics do you expect the element to possess? So here we have said that it is sonorous and ductile. What about the other properties? It is malleable, that is, it can be turned into thin sheets by applying force. It conducts heat and electricity, that is, it allows heat and electricity to pass through it. It is lustrous, meaning it has gotten a shiny surface. An element that is sonorous and highly ductile can be classified as a metal. Other characteristics include luster, malleability, heat, and electrical conductivity. Okay? So this answer, the category is metal and the other characteristics are malleability, conduction of heat and electricity and luster. Is it clear? Okay, so now we will proceed into long answer type questions. So here we have to write something more, something extra to gain marks. So we'll start. Okay. Under which category of mixtures will you classify alloys and why? Before I show you the answer, I want to make sure that you can recollect the answers. Under which category of mixture will you classify alloys? We classify alloys under the category of homogeneous mixtures. Okay, an alloy is a homogeneous mixture of two or more elements. Elements can either be two metals. We studied that alloy is formed by the combination of either two metals or a metal and a non-metal. So alloy is a homogeneous mixture. Now why is it a homogeneous mixture? It is because it shows the properties of two or more elements that it is made of. We studied for the formation of compounds, elements must combine chemically. In alloys, there is no chemical combination taking place. Okay, and in compounds, after the formation of a compound, it will not have any properties of the elements from which it is formed. But in case of alloys, after the elements are mixed and they are made to form an alloy, the alloy will have properties of the elements which mixed. Okay, and its constituents are in varied compositions. In compounds, it is mandatory that a fixed proportion must be followed, but in case of mixtures, that is not compulsory. It can combine in any proportion. For example, brass is an alloy that shows characteristics of copper and zinc, and its composition varies from 20 to 35 percentage. That is, the amount of these elements can vary. It is not mandatory that copper has to be always present in 80 percentage or 70 percentage. Its composition can vary. This is the reason why we call alloy a mixture and not a compound. Is it clear? Now, a solution is always a liquid. Comment. Is it? No, right? We studied several types of solutions. We studied solid and solid type solutions, solid and liquid type solutions, gas and liquid type solutions, liquid and liquid type solutions, and gas and gas type solutions. Right. So usually the most common examples of solutions are all liquids, but that does not mean that they're always liquids. It might also include a mixture of two solids like alloys, mixture of gases like in air. Is it clear? Usually solutions are liquids, but always they are not liquids. Okay. What is our question C? What is a term that you can employ to a heterogeneous mixture with distinct boundaries between constituents and non-uniform composition? Clearly points are given. It is a heterogeneous mixture. So while we studied different types of mixtures, we studied two heterogeneous mixture. One, a complete heterogeneous mixture. The other, a heterogeneous mixture that looks homogeneous. So here, to avoid that confusion, they have given extra points. We can see distinct boundaries between the constituents and there is a non-uniform composition. So what are we referring to? Are we referring to solutions? Are we referring to colloids or are we referring to suspensions? Yes, we are referring to suspensions here. Okay, it is a suspension, a heterogeneous mixture where there's a non-uniform composition in the constituents and there are distinct boundaries between the constituents. So suspension is the answer. Example you can write as sand in water. Is it clear? Okay, so now we'll move to our next question. What is our next question? A group of students took an old shoebox and covered it with black paper on all sides. They fixed a source of light at one end of the box by making a hole in it and making another hole on the other side to view the light. They placed a milk sample contained in a beaker or tumbler in the box as shown in the figure. They were amazed to see that the milk taken in the tumbler was illuminated, that is, the milk was glowing. They tried the same activity by taking a salt solution but found that light simply passed through it. By now, you might be aware what you're talking about, we are discussing about in the question, right? So this is a model. There's a tumbler containing the sample. They're looking through one side and they're passing torchlight to the other side. They've kept it in a confined black colored shoebox to make sure that to see the results visibly. Okay, to see the results visibly. Now, when they kept milk inside, what happened? The milk got illuminated and not much light passed outside. But when they placed salt solution, what happened? The light passed outside comfortably. So what are we talking about? What phenomena are we talking about? Explain why the milk sample was illuminated. Name the phenomenon involved. Why? What is the phenomenon? Yes, the phenomenon is Tyndall effect. Milk is a colloidal substance, and the particulate matter present in the milk makes the light scatter, which results in Tyndall effect. So the fat molecules, basically the globules of fat present inside the milk, makes the light scatter, and this results in Tyndall effect. So this is basically the milk glows, or milk gets illuminated because of scattering of light, and this phenomenon is called as Tyndall effect. What is the second question? Same results were not observed with a salt solution. Why? Because salt is not a colloid. And what is the major reason? What is like the principal reason for that? Because salt is a homogeneous solution or a homogeneous mixture. The size of particles in salt is extremely tiny. Small particles present in salt solution do not scatter light, and there will be no Tyndall effect. For solutions or for mixtures to show Tyndall effect, there must be a size criteria that the particles must fulfill. But in case of salt solution, but in case of homogeneous mixtures, particles are extremely small. They will not be able to scatter light, and therefore there will be no Tyndall effect. Since the salt solution did not exhibit Tyndall effect, light is not illuminated because the particles are too tiny to scatter light. Fine? Okay. What is our last question? Can you suggest two mixtures that would show the same effect as shown by milk? So you can write any example of colloids given in your textbook. Okay, colloids show Tyndall effect. The colloids show Tyndall effect throughout. Okay, throughout. Suspensions can show Tyndall effect only until all the particles settle down. After all the particles have settled, they will not be able to show Tyndall effect. But colloids will show Tyndall effect throughout. So any colloids you can write. Okay, here I've given the example of starch solution and fog. You can write any example provided in your textbook, which comes under the category of colloids. Is it clear? Okay. Next question. Classify each of the following as a physical or chemical change and give reasons. Okay, physical and chemical change. So we'll look at the changes and classify them into physical and chemical. Drying of a shirt in the sun. What do you think? First we'll classify them, then we look at the reasons. Drying of shirt in the sun. Is that a physical change or is that a chemical change? It is a physical change. Rising of hot air over a radiator. Rising of hot air over a radiator. What kind of a change is that? Are you confused? Hearing radiator and all. It's simple. Rising of hot air over a radiator. What happens in hot air and cold air? Cold air is dense, okay, so that it will settle on the bottom. But hot air is lighter, so it will rise upwards. So that is also, there's no new substance being formed there. So this is also again a physical change. Burning of kerosene in a lantern. I've told you all cooking and all burning comes under the case of category of chemical changes. Churning of milk cream to get butter. What is that? Is that a physical change or is that a chemical change? Churning of milk cream to obtain butter. Since you have studied about colloids, we know dispersed phase and dispersion medium. So what are we doing here? We are just separating them. There's no change. There's no new substance being formed. It's just getting separated. Okay, it's in this particular case, churning of milk cream to get butter. It's getting separated into buttermilk and butter. That's all. So this is again a physical change. Okay, so we look at the reasons. Drying of shirt in the sun is a physical phenomenon or a physical change because there are no chemical reactions or any chemical changes involved in this process. Water in your soaked clothes or your wet clothes just get converted into their vapor state while it's being dried. The rising of hot air over the radiator is a physical change. Water in a radiator converts to vapor. Hot air becomes lighter and rises. It's not necessary that always water converts to vapor and this air rises. The heat coming from the radiator itself will change or will heat up. The heat evolving from the radiator will heat up the air in the surrounding, and this will cause the air in the surrounding to rise up. Okay, so that is again a physical change. Burning of kerosene in a lantern is a chemical change because kerosene burns by using atmospheric oxygen and produces carbon dioxide. We have studied that equation for burning or the equation for combustion, right? Some substance, say any substance, but a kerosene here, kerosene also contains carbon mainly. So carbon plus oxygen giving carbon dioxide. So new substances are being formed while burning occurs, and burning always occurs in the presence of oxygen. So here again, this is a chemical change. Churning of milk cream to get butter is a physical change as there is no involvement of a chemical reaction. Here the principle is centrifugation, which turns the milk cream into butter. It just separates cream into butter and buttermilk. So it is again a physical change. So we have gotten 3 physical changes and 1 chemical change from the lot. Is it clear? Okay. Now, Arun has prepared a 0.01 percentage by mass solution of sodium chloride in water. Which of the following correctly represents the composition of the solution? So here it's basically a multiple choice question, but here it involves some work. Okay, so we have to find out the correct composition of the solution. 1 gram NaCl plus 100 gram water, 0.11 gram NaCl plus 100 gram water, 0.01 gram NaCl plus 99.99 gram water, 0.1 gram of NaCl plus 99.90 gram of water. So first, before looking at the answer, what is the question? Arun has prepared a 0.01 percentage by mass solution of sodium chloride in water. So when we discussed MCQs, I told you we'll be able to deduce something from this information given to us. 0.01 percentage by mass of solution. What does that mean? 0.01 percentage by mass means 0.01 gram of solute in 100 gram of solution, right? So here nothing in the options, nothing contains solution. What does it contain instead? It contains water, which is the solvent. So here we know that in 100 gram of solution we have 0.01 gram of solute. We are aware that solution is equal to solute plus solvent. Correct? Solution is equal to solute plus solvent. Now, mass of solution is equal to mass of solute plus mass of solvent. Since in the option only mass of solvent is given, only mass of water is given, mass of solution is not given. So we need to find out what the mass of solvent is. So mass of solution, we know it is 100 gram. Mass of solute, we know it is 0.01 gram. And we have to find out mass of solvent. Let's take that to be equal to x. So x is equal to 100 minus 0.01. What is the answer to this now? Now you do some mathematics. What is 100 minus 0.01? It is 99.99 gram. So we know that this solution, which is 0.01 percentage by mass, contains 0.01 gram of solute, which is NaCl, plus 99.99 gram of solvent, which is water here. So option C is the correct answer. Now, if you're confused, we'll do it using the formula itself. I have done it for you. Here, mass percentage is equal to mass of solute by mass of solute plus mass of solvent into 100. What is this mass of solute plus mass of solvent? Nothing but mass of solution. So that is how we have studied, right? So you can study the same way. Mass of solute by mass of solution into 100. So we'll take option C and work it out, okay? 0.01 divided by 0.01 plus 99.99 into 100. 0.01 by 100 into 100 is equal to 0.01 percentage. Is it clear? So your option C is correct. Okay. So now you'll be able to approach questions of this sort with ease? Yes. Okay. So now, again, a similar type question. During an experiment, the students were asked to prepare a 10% mass by mass solution of sugar in water. Ramesh dissolved 10 grams of sugar in 100 grams of water, whereas Sarika prepared it by dissolving 10 grams of sugar in water to make 100 gram of solution. So what is the difference? Ramesh used 100 gram of water to dissolve 10 grams of sugar. Sarika, she dissolved 10 grams of sugar in water and the total added up to 100 gram of solution. So you tell me who did it correctly? From what we've studied so far, who has done the mixing up or making up solution correctly? Sarika or Ramesh? We know, I told you, X percentage mass by mass means X gram of solute in 100 gram of solvent. No, 100 gram of solution. So here, just by looking at the question, we know that Sarika has prepared it correctly because she dissolved her 10 grams of sugar and the total after making solution went up to 100 gram. But here in case of Ramesh, he has dissolved 10 gram of sugar in 100 gram of water, which is wrong. Okay, so we can prove that mathematically also. I've done it. So what is the question? Are the two solutions of the same concentration? No, it's not. Sarika's solution is a 10% mass by mass solution, but Ramesh's is not going to be that way. Let's see what Ramesh's is. So the formula is mass percentage is equal to mass of solute divided by mass of solution into 100. Solution made by Ramesh. Okay, we'll do it side by side. Solution made by Ramesh. He dissolved 10 gram of sugar in 100 gram of water. So mass of solution is going to be 10 plus 100. So 10 by 110 into 100. What is the answer to this? This is equal to 9.09 percentage. What about Sarika? 10 gram of solute she dissolved and she made up a 100 gram solution. So this gave us 10% concentration mass by mass. So the solution prepared by Sarika has gotten a higher concentration than the solution prepared by Ramesh. And students were asked to prepare a 10% solution. So who did it correctly? Sarika has done it correctly. Okay, fine. Now we move on to case study questions. Question 1. A suspension is a heterogeneous mixture in which the small particles of solid are spread throughout a liquid without dissolving in it. If a beam of light is passed through suspension, it scatters the beam of light and renders its path visible only until the particles settle. After the particles have settled, it will not scatter light anymore. On the other hand, a colloidal solution appears to be homogeneous, but actually, in the molecular level, it is a heterogeneous mixture. Particles of a colloid are uniformly spread throughout the solution, and its particles are big enough to scatter a beam of light passing through it at all times. Read the given passage carefully and answer the following questions. Which one of the following couldn't be classified as a colloid? Blood, soap solution, chalk powder in water, and milk. What do you think is the answer? Blood is a colloid, soap solution is a colloid, milk is also a colloid, but chalk powder in water is a suspension. Okay, so option C is the answer. Which of the following solutions show Tyndall effect? Which solutions show Tyndall effect throughout? Tyndall effect is a unique property of colloids. So look for colloids. A solution of common salt? No. Sugar solution? No. Lemonade? No. Starch solution. Starch solution is a proper colloid. So option D is the correct answer. Size of particles in suspension, true solution and colloidal solution varies in the order of what? What do you think? You have suspension, true solution and colloidal solution. The size of particles in suspension is the largest, followed by colloid and finally true solution. Okay, so option A is the correct answer. Suspension has the largest particle, then colloid, followed by true solution with the smallest particles in the lot. Automobile exhaust is an example of what type of a colloid? We know that it's a colloid. What type of a colloid is it? It is a solid dispersed in a gas. There are solid particles, unburnt carbon called particulate matter. Okay, this is solid particles which are dispersed in gas. So solid dispersed in gas. Now we look at the answers. Something happened while we were presenting, right? Okay, so we leave that. We'll go back to our question. So we discussed the answers to the questions, and now you have to just write it down. Okay. So first one, option C, chalk powder in water. It is an example of suspension. Second question, option D, starch solution. A starch solution is a colloidal solution, so it will show Tyndall effect. Okay. The order of uh, the order of size of particles in suspension, colloid, and true solution, like we said, suspension has got the largest particles, followed by colloid, and then true solution. Option 4, what was the question for? Automobile exhaust is a type of what type of colloid? So it is a solid dispersed in a gas. So all the answers that we discussed were correct. Now, second question. A student prepared a solution of copper sulfate in water. The solution was blue and transparent. On passing light through it, the beam was not visible. When the solution was filtered, no residue was obtained. Read the given passage carefully and give the answer to the following question. So this was the passage. You have read it. Now we'll look at the answer questions. Solution of copper sulfate in water is an example of what? It is a mixture that we know, right? So it's definitely not an element. Now, what is it then? Is it a suspension? Is it a colloid? Or is it a true solution? For that, two clues are given to us. One, beam was not visible. It does not show Tyndall effect, so it is not a colloid. Then, when it was filtered, no residue was obtained. So it is not a suspension also. Suspensions, when you filter, you will be able to get residue. So what is residue? The substance that you get on the filter paper. If you take, for example, sand in water, that is a suspension. If you add it, what happens? All the water gets collected in the bottom, and on the filter paper, you will get sand, right? So that is residue. Okay. So here, all three options are cancelled. So what is the correct answer? A solution of copper sulfate in water is an example of a true solution. Why is the path of light not visible in this solution? Why is Tyndall effect not shown? Why can't we see Tyndall effect? Because particles are too small to scatter light. For particles to scatter light, they must fulfill a size criteria. Okay. What is the approximate size of solute particles in a true solution? What is the answer to that? The particles of a true solution is less than 1 nanometer in diameter. We have studied that, right? If you don't remember, look at the properties that you've written in your notebook, properties of solutions. So here the option is option C. Yeah, first one is a true solution. We've marked that. Second question, because the particles are too small to scatter light, we've marked that. Approximate size is less than 1 nanometer. That also we have marked. Okay, fine. Now we move on to assertion and reason type questions. So you will have an assertion, you will have a reason, you will have four corresponding options. You have to say which one is the correct option. Assertion, air is a homogeneous mixture. Reason, components of air cannot be separated by physical methods. So actually, air is a homogeneous mixture. That is true. Reason, the components of air cannot be separated by physical methods. Is that correct? We studied that in homogeneous mixtures, components cannot be separated by simple physical methods like filtration. That does not mean that homogeneous mixtures cannot be separated by physical methods at all. Simple example, salt solution, salt and water. How do you separate it? You simply boil it. right? So we can employ physical methods, but filtration or methods that employ size criteria as a factor, that we cannot use. Components of air are actually separated by fractional distillation, which is again a physical method. So which option is correct? The assertion is true and the reason is false. Air is homogeneous, but its components can be separated by physical methods like fractional distillation. Is it clear? Okay. Assertion: a mixture of salt and water is a homogeneous mixture. It is, right? Salt completely dissolves in water and forms a single phase. Listen, salt is actually without dissolving, salt is solid, whereas our water is liquid. But when we dissolve salt completely in water, it becomes a single liquid, that is a single phase, right? So both the assertion and reason are true, and reason is the correct explanation of the assertion. Okay? Okay. Third question, assertion: colloids show the Tyndall effect. Reason: size of particles in colloids is large enough. Sorry, there's a mistake here. Okay. Size of particles in colloids is large enough to scatter light. So which one is the correct option? Both A and R are true and R is the correct explanation. Both A and R are true, R is not the correct explanation. A is true, but R is false. A is false, but R is true. So what is the answer? Question is colloids show Tyndall effect. That is true. Size of particles in colloids is large enough to scatter light. That is also true. So the option A is the correct answer. Both A and R are true and R is the correct explanation of the assertion. Fourth question, filtration can be used to separate salt from salt solution. Is that true? No, filtration cannot be employed. This is what I told you. Homogeneous mixtures cannot be separated by using simple physical methods, which is based on size. Filtration separates based on size of particles. Reason: size of salt particles in salt solution is smaller than the pores of the filter paper. That is true. Pores of filter paper are larger than the size of salt particles. So what will happen? Salt will easily pass through the filter paper and come get collected in the beaker if you try filtering it. So here, what is the correct answer? Option D is the correct answer. Assertion is false, but the reason is true. Is it clear? Okay. So with this, we've come to the end of our discussion. So we've discussed multiple questions belonging to different categories, right? So what do? You go through the material provided to you again, go through the video again, try answering questions by yourselves, okay, and then you look at the answer key and then match your answers with the answer key. So I hope that this session was useful to you, and I want to make sure, and I hope that you guys ensure that this session, you are going to make use of this session by watching the video and clearing your doubts. Okay, I wish you a very good night. Thank you.